Let's go.
Keep going. All right, so I'm going to discuss Depop a little bit here today. Status, a little bit of an overview, some open issues, so forth. Depop, roughly short for OAUTH 2 demonstration of proof of possession at the application layer. As everyone knows, I like to throw in a few photographs in my presentations. Unfortunately, we didn't make it to Vancouver here, but I can still appreciate the city. So with that, we'll get started. Quick overview, refresher, kind of introduction to Depop. The idea is a new-ish, anyway, simple and concise approach to doing proof of possession for OAuth access and refresh tokens, and doing so at an application level using existing JWT library support to make it something that people can actually do and implement and deploy in a relatively simple fashion. It's not super easy, but the idea is to be something that regular developers can actually do. The basic Depop flow comes down to the usual OAuth flow here, where you have your token request to the token endpoint to get the access token, and then you have your resource access. And what's unique about Depop is that there's this concept of a Depop proof that's sent in the same way, using the same syntax and semantics, both to the authorization server on the token request, as well as in conjunction with the access token on resource server access. And it travels in an independent header, and it happens the same way. When you make the token request, the Depop bound access token is returned, and possibly also the refresh token is bound as well, but only for public clients. Key takeaway here is, I think, that the Depop proof mechanism, which is what's used to say what the public key that the client holds and give some level of proof that it holds the corresponding private key, is the same on both the token request and on any access token or any protected resource access. That Depop proof itself is a JWT. It looks a little bit like this, exploded out or unencoded. It has a type, it's explicitly typed asymmetric signatures are the only ones that are supported for this. And then the JWK header of the proof contains the public key for which proof of possession is being demonstrated by the client. And then it's a JWT with some minimal claim information about the HTTP request, basically the method and the URI of the request, omitting any fragment or query parameters. There's a unique identifier in there, which we're currently using for some replay checking, and a timestamp with some conditions around suggesting that the proof itself only be accepted for some small, reasonable time window relative to that creation time. In an access token request, this is a request to the token endpoint, the Depop proof is set as the header. It'll be the same for both types of requests, but it's sent here, you see, as a Depop header, and the encoded JOT there is included directly in the header. And that, again, is proving possession to some extent of the private key corresponding to the public key that's in that proof with respect to this particular request. And then the rest of this is just standard OAuth stuff. You see this as an example of an authorization code exchange. Presuming that all checks out, the access token is issued like normal, but the access token itself is bound to the public key that was in that Depop header. And then we use the token type here to indicate to the client that this access token, and only the access token is indicated by this, is bound to the Depop public key. That access token might look something like this for both JOT-based tokens and tokens that are introspected. We defined JKT for the SHA-256 JWK thumbprint of the public key, and that indicates and does the binding of this particular access token to the public key that the client's asserting through the Depop proof. Obviously, this could be done, internally too, if it's a database lookup or something, but we've concentrated on defining the pieces needed for interoperability here, which would be in a JWT or via introspection response. And this works similar to also other types of access token binding that we're doing today, such as the MTLS stuff that was recently with RFC. On a protected resource request, then we have sort of two elements. One is the authorization header. Instead of being a bearer token, we're using the newly defined DPOP scheme here, and that public DPOP bound access token is sent in as the access token, obviously. But that happens in conjunction with the DPOP header containing the DPOP proof being sent as well. The proof is what actually does the proof of possession of the client held key. And then in addition to the normal checking of the stuff you would do for an access token, the protected resource also needs to check that the binding of the key to the access token matches up to the key that was sent in the proof. That's kind of a quick overview of how things work, hopefully quick anyway, and jump into sort of current status and updates to the specification. We had the 00 working group draft was published back on April 1st. Not a joke, despite the penance for in the IETF here. And then just recently, last week, I published 01, and with some updates, some maybe not insignificant, but hopefully not function breaking editorial updates to hopefully clarify a few things. I went in and I more formally defined the DPOP authorization header scheme. It was implied previously, but there was no actual definition of how that worked. And in conjunction with that, also defined a 401 in conjunction with the www authenticate challenge. So now there's an actual 401 challenge that can be sent from the resource server, either for an invalid token or a protected resource request with no token available. And it has the things you would expect to have in the response, like the scopes and a bit of error messaging if needed. I also added a ALBS param to this challenge, and this is an opportunity for the resource server to indicate the supported algorithms that it supports for checking and validating the DPOP proof. So this gives some way for the resource server to indicate which algorithms it can support. Also added a new error code for errors in the token request, maybe not strictly necessary, but a nice sort of subcategory to say what's going on there. Fixed up and added a bunch to the IANA section, trying to register all the various different pieces here, which was actually useful because it helped sort of bear out some pieces that weren't fully defined, like the authorization header scheme, as well as the need for the challenge sort of fell out of that as well. In terms of understanding what algorithms are supported, added a authorization server metadata parameter which is a array of the JWS algorithms supported by the authorization server. So there's two. The authorization server has metadata to indicate the DPOP algorithms it supports, and the resource server can use the challenge to indicate the algorithms that it supports. And just mucked around a little bit, moving the acknowledgements back into an appendix, and added a bunch of names based on a best effort I could make looking back at emails and so forth. As usual, if you feel like I've admitted you here, it's not at all intentional, please just let me know. It's hard to sort of track back all this stuff. So going from there, I'm going to jump into some open questions that have come up from a number of places, discussions here. I understand there were some pretty good discussions last week at the IIW workshop. And then I do want to acknowledge there have been a couple emails that came in this morning with reviews that I haven't had a chance to go through fully. Although I touch on some of the issues in this, unfortunately, I haven't had the time to incorporate all that. From earlier this morning into this presentation. So this isn't an exclusive list of open questions, but hopefully it covers a lot of it. So in general, the threat model and objectives that we're trying to deal with have come under some criticism and need for some improvement a few different times. And honestly, they're not entirely clear in the document. I think we're all pretty well aware of that. But they're also sometimes maybe overly specific. There's some real specific content discussing the particular prevention of one resource server replaying a token to another, which is an important use case to cover, but I think it's maybe overly emphasized to the point where there's not not understanding discussion, or at least clear explanation that the general cases of binding tokens can be useful as well. It's been a sort of a problem because this whole thing is sort of a Rorschach test. Like everyone either sees what they want in it or not in it, and there's a lot of cases that bound tokens can help with. That I'm not sure we want to list them all specifically, but it's also would be helpful to generalize this, I guess, a little bit more and give a better explanation of the threat model and objectives that we're trying to do here. And as you hear me sort of stumble through even explaining this, honestly, I'm hoping that Daniel and his fancy education in the Greek can help with some of this text here, as he did write some of the initial stuff, and I've struggled to update it. But in conjunction with that, he's also given a few slides that I've incorporated here to discuss this a little bit more. And I would like to hopefully hand it over to him just to speak to these. Are you available for this?
Yeah. So I see Dick in the line. Do you want to take comments now, or do you want to wait?
Well, we can take them. We are going to be tight on time here, but please go ahead.
Yeah. Okay, go ahead, Dick.
Hi, can you hear me?
Yes.
Yes.
Yeah, I got in the queue because it looked like you were going at the threat models, but I had a question on more some of the objectives of this. I'm curious why it seems to me, and maybe I'm misunderstanding it, that you're defining a new access token somewhat.
No. We're defining a new authorization scheme, but it's not.
Well, in slide 7, it's you've got sort of DPOP bound access token.
Yes. So that's not meant to be a new access token so much as just giving an example of an access token, this one in JWT format, that includes the confirmation claim here, the CNF, as the mechanism to actually bind to that public key.
So I'm wondering why you didn't sort of pull back and think of it as to how you could have this work with where you're treating the access token opaquely, so that then the DPOP could work against any access token, because the JKT looks like it would need to be that the access token would have to be a JWT.
No. This is just an example, sorry, of what a JWT would look like for interoperability purposes. It's still opaque to the client, as it always is. But when you're ultimately the resource server has to know something about it. So it's either going to read the JWT, look for the confirmation claim, introspect it, and look for the introspection response parameter, the same name with the same semantics, or do it by database lookup, or however it would be done internally without any sort of interoperability concerns. But we've concentrated on defining the CNF claim here because JOTS and introspection are the sort of semi-standardized ways of conveying this information. But it doesn't have to be done this way if there's some other proprietary mechanism occurring between the RS and AS.
Getting at is you're requiring the JKT information to be in the access token, where potentially you could have the signing be totally a layer above it, so that you're not changing the access token at all. Since you do have a detached token happening at it, you could go and define the DPOP piece to be something that, so you're not making any changes at all to the access token, which would enable somebody to go and add this as a completely independent layer on what they're using already.
I'm not sure I fully understand how that would work.
Well, say if you're viewing the token just as an opaque string, in the detached signature, you could have in the detached in the depop parameter, you could have something that's a hash of the access token and some signing mechanism, so that then you know that that depop token is associated with that particular access token without making any changes to the access token.
Okay, I mean, not making any changes to the access token was in no way a desired requirement or objective of doing this. So I guess it didn't consider that. And the depop proof also is sent directly to the authorization server as part of the whole mechanism, in which case there's no access token involved. So
in the slide 8, though, you're sending the authorization, right? So that could be the same as usual. And then the depop would be able to prove proof of possession for that access token as a regular bearer token. Anyway, I was wondering if there was a reason why, why you hadn't done that, or was it maybe you just that didn't come up as a requirement? Yeah.
It wasn't, it didn't come up as a requirement, it didn't seem necessary, and it didn't fit in particularly well with some of the other pieces of how it works. I mean, there's a lot of different ways to approach some of these things, but some of this was done to be following existing patterns of how we've worked with other sort of proof of possession type tokens in other RFCs. And and just not being a sort of primary objective, I guess would be the reasons. But it sounds like somebody else wants to comment though.
Maybe I can say something on this. Daniel here. So at the end of the day, the depop proof is really kind of independent from the from what is in the access token. So the depop proof works the same way, whether it's an JWT access token or an opaque string or whatever. This is just a nice piece of information to tell the resource server that this access token is bound. And if you don't want this in your access token, you can still use introspection.
That's correct, but the introspection response would look very similar to this because the resource server still needs the data. If you're not doing any of that, you can store it in a database or however you want to do that and convey the data in some other way. But these were done for interoperability.
Okay, so I see a few people in the line here, so let's give them a chance. Justin?
Yeah, I wanted to chime in. I think you guys have mostly covered it, but yeah, Brian, if you could actually go to slide 8, please. Yeah, the one example. Thanks. We have implemented at OAUTH, we've implemented depop, and the default mode of OAUTH is with an opaque string. It's a random blob token. There's no data in the token itself. It's used as an index into storage, blah, blah, blah. Regardless, our storage mechanism has reference to the key that was used in the depop proof, and that's what we use to recalculate and validate the signature for both token presentation at the RS and also for refreshes and all of that other stuff. So this work does not change what an access token is. It does not change what is in your access token. All it requires is that the RS is able to figure out which key it needs to know about in proving the access token. That's how they're bound. And depop doesn't actually dictate how you do that. Instead, it provides a couple of interoperable patterns that you can use based on existing standards that are already well established for bearer tokens to allow you to do that. So this does not change what an access token is at all.
Well said. Thank you, Justin. That's absolutely the intent. I do think the text could be worked on a bit to clarify that it doesn't require either of the well-established patterns, but they're provided there for interoperability. But yes, thank you.
Okay, Annabelle?
Annabelle Backman, Amazon. Sort of as one of the things that's come up a little in this discussion is the idea of sort of not changing the access token, not changing how the access token is processed or being able to sort of treat Depop as a completely independent layer on top of that. I think this touches on something that'll come up in the slides later, but there's some security risk in that. In that, if it isn't clear and obvious that an access token is a Depop access token, and if it is possible for a relying party to process a Depop access token as a unbound bearer token, then that creates a potential downgrade vector. If you've got clients that are expecting to, if you've got a deployment that's expecting to be sometimes issuing Depop access tokens and sometimes issuing bearer tokens, which is a pretty likely scenario if you've got clients that are upgrading at different points in time. So we need to be very careful about what kind of model we're pushing out there, and how that's going to play out in the migration story for some of these for deployments out there.
Okay, Andreas?
Hi, I'm Andreas from Novatec. Yes, the last statements clarified my question already. So I was also questioning myself how that works with opaque tokens. So maybe some sentences to make it more clear would be good for the specification, that it's not only working with JSON Web Tokens. That's all from my side.
We'll seek to clarify that, yeah.
Thanks. Brian, you have 7 minutes, so you wanna maybe 7, 8 minutes, so you wanna maybe.
Sure, so yeah, Daniel, you wanna?
Yeah, I'll keep it short. So I think over time, we have kind of conflated all the attacks that we want to defend against using Depop. And therefore, I took the time to kind of unconflate this, or at least try to. And it turns out we have like 3 or 4 different kinds of attack that Depop possibly defends against. Due to our time constraints, I propose that we post this on a mailing list and discuss there about this, so that everybody has time to look into these attacks. But just one interesting thing that I found during a recent analysis on the mix-up attack is that if an attacker uses metadata as it is shown here on this slide, where the user info endpoint, where the authorization endpoint and token endpoint point to an honest server and the user info endpoint points to an attacker, then Depop, or another sender constraining method, is actually really useful to protect the access token. And this is I think one of the most critical attacks that we want to defend against, and Depop enables that for things like SPAs and so on. So yeah, let's post this on a mailing list and discuss there. So this and the next 4 slides or something like that.
Thanks. So one thing that's come up a few times is the inefficiency of asymmetric crypto. It is inefficient, but there's other costs involved in doing something different. So far, we don't have any real world quantified implications of this. And it's true, but I don't know how much of a problem it is. There's been a couple of different potential approaches that were thrown out there. One is to do like a key distribution, another is a key agreement. I'm sure there's other ways. But basically, I'm working off of the idea that I consider this code now coming out of the meeting we had before the full 107 and then the general working group adoption of the document. There seemed to be not enough interest in pursuing something different, something concrete, and so we're kind of going with this for now. Another issue has been raised is the difficulties around JTI. The point being that detecting and preventing replay with JTI can be very problematic for large-scale deployments. And this can also exacerbate problems with inefficiency around asymmetric crypto as you sort of scale out horizontally. If you're tracking JTI for replay, you lose some of the value of that scale out because you still have to coordinate amongst those horizontal nodes. There's also potentially some unexpected issues with idempotence and retry attempts if you're catching sometimes but not other times the JTI. The current situation right now is that the replay is also sort of prevented by the timestamp in there. And the text in the document says that the replay check on JTI is only a should. And there's places where it's qualified with text, like you should only do this within a reasonable consideration of accuracy and resource utilization. That's intentionally put in there to allow for large scale deployments to not be a hard must that JTI replay has to be prevented all the time, but more of a should be with consideration for the rest of your deployment. It still seems to be considered a problem, so some options around this. Further would be to further mention that the replay place that you care about, you have to check, is qualified by the URI and the method. So the scope of the data replication of the JTI, even if you're trying to do this, is definitely smaller. There was also a mention of splitting out the path from the HTU claim, but I'm not actually sure how this helps. We could further sort of loosen or qualify the requirements on checking, making it a may or even non-normative text, sort of like encouraging it, but not putting any normative requirements on it. The requirement for replay checking could be, or the requirement on checking the JTI could be dropped altogether. I think a bullet got cut off there. There was sort of just, we could do something else, undefined, but brainstorm it. I'm just going to proceed at this point. I'm not sure what to do with the time constraint.
Hold on. So I think Annabelle is in the line. Do you want to maybe give her a chance to ask her? Okay, go ahead, Annabelle.
You know what? No, just Brian, keep going with your slides.
Okay. I'm not gonna get through them either way.
You still have three minutes. You're gonna.
3 minutes. Okay. It's come up that it would be useful maybe to have a signal the refresh token is bound. It was noted that token type is the same regardless. Note that token type from RFC 6749 only applies to the access token. That's how it's being used here. But in the current situation in the document, refresh tokens are only bound for public clients. This came up a few times this morning and apparently needs some better explanation in the draft. I'll definitely take a look at doing that. I'll note that, and this gets to larger issues, but the Depop access tokens are almost certainly usable as plain bearer access tokens as well. But there's been questions that maybe the client needs some kind of signal, public client, that the refresh token itself has been bound, even if the access tokens aren't. So maybe a bearer access token response with a bound refresh token. And so one potential approach to doing this, we could easily define a new token endpoint response parameter that is used as a signal to the client that the refresh token has been bound. The name here is obviously not a real suggestion, but conceptually it could be something like this that just isn't used as a signal to the client that that's happened. There's been discussion of client metadata. Some people seem to think we should do this. I cannot see the actual utility or usefulness of the client metadata. So I'd sort of like to understand how that would actually be used before we go about introducing it. This one is, I'm not sure where to start with this. Basically, I made a change to some of the text that caught Fleet's eye here, and he's suggesting that in RS, we have something requiring an RS also check when any time that there's a CNF or a JKT with a JKT in the access token or a reference to by the access token, such that a Depop access token couldn't be used as a bearer token. And in my opinion, as I say here, obviously, we don't want to do this. And in reality, I don't think we really can. we're not in a position to retrofit requirements onto bearer access tokens, both in the standards worlds or the implementations. And currently in a JWT, the unrecognized claims are a must ignore. In introspection, it's not quite as clear, but basically it says you can add extra stuff here, service specific. 6750 is sort of silent on the topic. And basically, in my mind, what this means is that if you took a Depop bound access token and stuffed it in a bearer authorization header, almost all implementations, I think, would accept that as a protected resource request and be fine with it. And while there's the potential there for downgrade type attacks, there's also the ability then to roll out and have mixed token type deployments where you don't have to necessarily distinguish between the two. A service that only supports bearer tokens could accept a Depop bound access token and continue working. A service that only accepts Depop access tokens would be coded and designed to do that and make the appropriate challenge and response. And then if you had a mixed mode on a particular server, you could of course have policy and implementation that would only allow certain access if it was only bearer, or further check these things and respond with the right challenges to indicate what the client needs to do. But I guess my point here is that the current situation of allowing this to work this way, relying on existing implementation, actually aids in the sort of temporal rollout of new functionality working in conjunction with old stuff.
Okay, Brian, your time is up, so let me give just Philip a chance to chime in there.
Yeah, very quickly. I understand the time constraints. I just want to clarify the intent of the issue. It was not to have the existing resource service altered in any way. It is specifically for the issue that Annabelle mentioned, when you have a gradual rollout of the Depop scheme, where for the time being, depending on the user agent support, you may support both bearer and Depop. In that case, if a client actually gets a Depop type access token, the resource server needs guidance on actually not only relying on the use of the Depop scheme, but also check the confirmation being there, because it already supports Depop. And in that case, if it detects a supported scheme through confirmation, but the scheme is different, it shouldn't allow access. That was the whole point.
Okay, thank you guys. I've cut the line already. So, sorry, Mike. I cut the line there. I need to give William a chance to present his slide. Sorry, guys. Thanks, Brian. And let's switch gears here. So, William, go ahead.
Right, can people see the slides here?
Coming, yes.
Yeah.
Okay, so this one's incremental auth. I'm just going to give a quick recap of what this is, just in case there's new people here or someone who hasn't read the draft. So the problem statement is essentially this, that an app or a website asking for like the kitchen sink of scopes up front is considered a bad thing. And the more correct approach is that users should have context of the authorization request. So one example of that is, let's say like an app has features related to calendar, maybe it has features related to like contacts, and they're kind of in different places of the app. All right, is that better?
For me.
Thanks for that. So the example is, let's say an app has like two different features, and instead of the app like asking for everything up front, it can actually just ask for each different scope in the context of that feature. So for example, if it's doing something with the calendar data, it could ask for the calendar data only when the user kind of gets to that part of the application, and it can ask for the other scope when the user exercises that other functionality. So this is an example of a screen, I think, which would be kind of the ROG approach. This is an app, like, let's just say this app, it has like all these different features. It has like some YouTube you know, it can do something with like videos, it can do something with calendars and contacts and Drive. And so it asks the user for like everything up front, even though the user may have come to this app only for one of those kind of bits of functionality. So not only is this kind of bad for the user privacy because they're giving more than what they would need to give to use the app, I also think it's bad for the app or the website because it means that a lot of users would decline this and not get the benefit of whatever's being offered. So to fix that, and the definition of incremental auth then is the ability to request additional scopes in subsequent requests adding to a single authorization grant that would represent everything that had been granted so far. So the single authorization grant is kind of important here because right now with OAuth, you could simply just do new OAuth requests and kind of maintain separate grants for each separate scope that you've asked for. But that then is kind of a burden to the developers. They need to sort of keep track of all these different things. So the benefit here of incremental auth is that it does kind of add the grants into a single kind of running authorization grant that the client can use for all their requests. So it implies then that the access token and refresh token kind of carry the union of all the granted scopes so far. All right, so with that, this specification proposes two methods for achieving this. The first is designed for confidential clients. So the benefit here of confidential clients is that, you know, in theory, they can't be spoofed or impersonated. So with confidential clients, it defines a new parameter called include granted scopes, where essentially they can make any request for any scope, any single scope. And if they add this parameter, it indicates that they would like the authorization grant to come back and include any scopes that have been granted in the past. There is also a public client protocol. Also, this is one, I guess, for clients that can be impersonated, which is typical of public clients, but not always the case, in fact, as I'll talk about a little bit later. And this one defines a slightly more complex method, which is a token endpoint parameter called existing grant. So the problem here is that at the time of the authorization request, the server has really no way of knowing that this is in fact the same client that you know has an existing grant, because it could be an impersonation of a client. So the way that this client can essentially prove that it does in fact, you know, have that previous grant is supplying that previous grant during the token exchange. So when the code is exchanged, it just passes in its existing refresh token, which is perhaps better illustrated on this diagram here. So, you know, the first kind of block is a very, very typical OAuth flow, resulting in the client, in this case, a public client being an app, having a refresh token and an access token to that first grant. And when it comes time to the incremental request, it just requests the second scope, so scope B in this case. It gets back an authorization for scope B. So at this point, it essentially has sort of two separate authorizations. But when it exchanges the code for the refresh token of the incremental auth request, it passes the refresh token from the first one in that existing grant parameter. And what it gets back is a grant covering both scopes. So like that. Okay, so getting on to the updates and the discussion. Firstly, thanks everyone for their feedback. And Annabelle, I actually apologize that I missed your email when I was addressing the comments. So I just took a look at it and will respond to you shortly for your points. But the updates in this version, I clarified some information around the 8414 metadata field, added a little bit more information about the scope responses. You know, if it's always possible to get back kind of less scope than what was requested. So I've just added some, in a way that was implicit, I've just added some sort of explicit text discussing that may happen. I also defined a new error code. So this spec previously did talk about the idea here that if an authorization server got one of those, you know, overbroad requests, like the one I illustrated at the beginning, that they could reject it. I realized actually going through Aaron's feedback that, you know, maybe it's appropriate to actually have a proper error message to indicate the reason that it was rejected. So I just quickly defined one called overbroad scope. just as a way of explicitly saying that that was the reason it got rejected. And I documented a little bit more behavior if the user reduces the scope there. Now I do have an open question. I'd be interested to get people's feedback on this, of course, and anything else. But as I presented this, there are sort of two approaches here. And originally I documented them on public and confidential clients, which kind of, but not exactly, maps to sort of impersonation proof and impersonation vulnerable, being the public ones are sort of vulnerable and the confidential ones are not. On reflection, I guess like a year later now, I realized that this is, there are potentially public clients that are impersonation proof, perhaps ones that are using HTTPS schemes and things like that, where you can actually, or even some key exchange or whatever. So I'm wondering actually if kind of just repositioning those two approaches defined in the draft from public and confidential to just kind of, I need a better or a more succinct way to say this, but like, clients that can be impersonated and ones that can't. I don't think that's a normative change, but it might just help the structure of the doc a little bit. So in terms of what an API might look like, this is just purely for illustrative purposes. Sorry.
Yeah.
Yes.
Sorry. Do you want comments now? Or do you want to wait to the end? Because
yeah, actually that'd be good. Sorry, I don't actually see the chat on my presentation view here, but
in the line. So
okay.
Annabelle, go ahead.
Annabelle Backman, Amazon. Yeah, I'll look forward to seeing your responses to the email comments. Couple of quick things regarding impersonation, vulnerable proof versus public confidential. I think, if I'm not mistaken, if you look at how confidential is actually defined in 6749, it really is just, can this client authenticate itself to the authorization server in a secure way? Can it does it have credentials that it can keep secure, basically? Which I think actually covers what you're trying to capture with impersonation vulnerable and impersonation proof. I think the confusion comes in that people have tended to equate public with native app and confidential with web application with a backend, and that's not necessarily the case. It's more nuanced than that. I do want to bring up one other concern that wasn't I didn't mention my email, that the process, the proposal you have where we are sending the existing authorization in the token request precludes the authorization server from informing the resource owner, the end user who's consenting, of the total sum of permissions that are being given to the client. So there's context where the end user may be interested in that, may want to know, oh, I've already given this app XYZ, now it's wanting ABC too, and that's maybe that's going to change my decision there.
Yes, that one, I did think about this, and even thought about having an authorization request parameter as well. The main problem that I see with this, and if you have a solution, I'm all ears, and that is that there's no real way to prove. Well, it's sort of hard, I guess. There might be a way, but it's harder to prove that the client is in possession of that grant at the time it makes the request. And essentially, if it sort of said, "Oh, I have these scopes," that's sort of in a way that's unproven. That could lead to a problem where I guess the user might be presented a screen that says, or the app already has like these two scopes. Do you want to add one more? And that may kind of increase their trust. Whereas this app could actually have nothing; it could just be sort of pretending.
So there are two thoughts on that. One, you could still require the app to present the authorization token at the token endpoint. So whatever it's sending over in the authorization request, the token itself or a hash of the token, something like that, is sort of indicating their intent, and then the token endpoint request, the token request actually confirms or proves ownership of that. Other possibility is PAR could solve this, right? Like if you're doing push authorization requests, then you can be a little more comfortable about what's happening there, and you're not pushing any tokens or such through the URL, which is great.
Yeah, yeah. No, I guess we could do like a hash or something.
Okay, Dick.
Yeah, just to slightly correct Annabelle's comment around confidential clients. The definition when originally created was that the client could keep a secret that the access server had provided it, and that the access server knew which client it was and had decided that, yes, that client's okay to do these certain types of things. And now we've got the idea that the client can, keep a secret, but that's not quite the same as the confidential client. And I think we're struggling sometimes because we have this new type of client that isn't really a confidential client and isn't really the full public client that maybe we need to address. On the incremental auth, I'm just wondering, maybe it should only be for confidential clients, and maybe using something like PAR or some other mechanism would be the appropriate one for these other types of clients that are sort of between confidential and public. Is there a demand in, William, for this to be supported by that other category of clients?
Yeah, I guess I hadn't thought about it in the context of PAR. I think there is demand. So this protocol we did implement on the Google OAuth server for the purpose of public clients, or like specifically like apps, being able to do the kind of incremental auth that I defined here. So yeah, I guess the motive of this draft, in a way, the motive of this idea is to improve the user experience by giving them a more granular way to like give grants. And so not leaving out any client, I think, is probably best to achieve that end.
Okay, Torsten.
Hi, this is Torsten speaking. Hi, William. I've got a question. I've been working with others on a grant management extension to OAuth in the FAPI working group, and we evaluated your draft that could as a potential foundation for that.
Okay.
What I realized when reading the definition of the include granted scope parameter, as far as I read the text, it doesn't really ensure that the AS is gonna really to use to extend the grant using the existing scope values and the new scope values that the grant asked for. Why I came to that conclusion? It says, when true, the authorization server should include previously granted scopes for this client in the new authorization grant. And that, in my opinion, somehow reduces the usefulness of the draft. Because as far as I understand, what you want to achieve is that the client developer doesn't need to keep track what scopes values are associated with a certain client ID or a refresh token. Instead, it can just incrementally ask for the scope values that for a certain use case, a certain situation are relevant, but the AS makes sure that all the other scope values are kept. And this little should, from my perspective, means, from my perspective, looking at that from an interoperability perspective, I can't be sure that the AS really honors that parameter, even if it supports the parameter. So can you please comment on that?
That's a good point. So your suggestion here is essentially, if that was a must, then it would be more useful for you.
Then as a client, I could rely on that.
Right. No, that's a really good point. And I guess, one of the confusing things about OAuth, and in Annabelle's email, actually, this is raised as well, is that, the server can always override anything and kind of return whatever grant it wants. So, but I guess a must here wouldn't preclude that. So,
I mean, in the end, you can never override a user decision, or a authorization server's policy decision. But at least if none of those contradicts what you asked for, the client should be able to really rely on the AS to use the old scope values and add the new scope values to that grid. So I think that would be very, very useful.
So I think, yeah, I think what you said makes sense. So I think this should be a must, but maybe a must with an asterisk to say that this is not overriding the ability of the authorization server to always downscope, which is always kind of its right, if you will, under the old spec. But
then it's a decision of the AS and the user towards the full scope of the grant, I guess.
Yeah. So I think I agree with you. I definitely understand that. Yeah. What's the sort of point, like if the server were to declare, hey, I support this thing, and yet it's a should, and so it's kind of wishy-washy support. Yeah, that makes sense. You either support it or you don't, I guess. Okay. Yeah. I'll take that update.
Okay, Annabelle.
Yeah. I think the problem with that line that we're just talking about is that it's talking about requiring the scopes in the authorization grant. It should actually be saying that the AS must treat the authorization request as if those previously granted scopes were requested within it as well. Because that's really the intent here. You know, we want the AS should treat this request as the client asking for what it's already been given plus this new stuff. And that would eliminate the need for your asterisk and any confusion over how that fits with the AS's ability to make decisions, or the end user's ability to say, no, I don't want them to have that one.
Yeah, no, it makes sense. One of the challenges I always find writing these specs is that OAuth is very unprescriptive as to kind of how the consent experience is handled. So
I don't say.
So I do get into that a bit later in the doc, and it's very hard to phrase it without making kind of a lot of assumptions about what's going on. So I think, like, if I can say like an unstated assumption in your comment just then is that the user would see those other scopes. And Naveen made a similar comment that that it would be good to show that. I find this hard to capture because like the old spec never even said you need to show that at all. It just sort of turns out that's in practice what everyone exactly did. I don't know. Maybe that's something that should actually be covered in the refresh doc, I guess. But okay. Yeah. Thanks for the comment.
Okay, I think the queue is empty. So, do you have any more slides?
No. Well, not really. There's just some background material. I do have one more slide, I guess. This is just an example of some code that's running if people are interested. But yeah, we definitely got through everything. Thanks, everyone. That was actually really useful. I'm going to do another couple of rounds of iteration to capture all this feedback, and then hoping to advance the draft, I guess.
Okay, awesome.
Thank you.
Thank you, William. Anybody has any last-minute comments, questions? Okay, we'll see you next week. So, go ahead, Annabelle.
I wanted to ask if we're going to have additional time to go over more of PAR, or is it worth scheduling another round of meeting for that?
If needed, yeah, we'd be happy to do that. Let us know. Torsten, is that your document, right? The PAR?
I'm sorry, not PAR. Depop.
Depop. Okay.
Okay.
Okay, Depop. So Brian and I think Daniel, would you like to have another session to discuss that? Okay, I see Daniel. Okay.
That probably makes sense. Yeah.
Okay. Awesome. Sure. We'll schedule.
We got cut off on part 2, but I think we got a lot of good stuff worked through on the mailing list. We're waiting for we'll do some revisions there.
Okay, sounds good. We'll try to schedule then one more session in addition to the one next week. So we'll see. Okay, awesome. Anything else? Oh, for longer meetings. So yeah, keep those comments coming, but let's do that next week, Dick. That's good. Good feedback. Yeah. Okay.
Bye.
Thank you, guys. Bye.
Thank you.
Bye.